Hey, space enthusiasts and science fans. Welcome back to our channel, where we dive deep into the latest and greatest discoveries that leave us in awe. Today, we're zooming into a groundbreaking revelation that has the entire industry buzzing. The James Webb Telescope, humanity's most powerful eye in the sky, has made a discovery in outer space that has left scientists and astronomers absolutely amazed. Stick around as we unveil this cosmic marvel and explore what it means for our understanding of the universe. Imagine unveiling cosmic mysteries so profound that even the most experienced astronomers are left astounded, their jaws dropped in disbelief. This is precisely the impact of the James Webb Space Telescope's latest voyage through the stars. It has revealed wonders so striking that they're revolutionizing the space sector. From discovering a galaxy that hosts a black hole challenging our existing scientific paradigms, to detecting an unusual light signal emanating from unexplored cosmic realms, these breakthroughs are not merely additions to our space saga. They are transforming the narrative of the cosmos itself. Scientists wielding the James Webb Space Telescope have identified the oldest black hole ever observed, nestled within a galaxy known as Gien's 11, an astonishing 13.4 billion light-years away. This black hole serves as a cosmic portal, offering us a glimpse into the universe a mere 400 million years post-Big Bang. Its mass is staggering, clocking in at around 6 million times that of our Sun, and it's consuming material from its galaxy at an unprecedented rate, far exceeding what our theories had anticipated. Roberto Molino, the leader of the research team from the University of Cambridge, has hailed this discovery as a monumental stride forward. In the realm of black hole research, there's a sense of bewilderment due to the appearance of such a massive black hole so early in the cosmic timeline. It's as if the universe is presenting a mystery. How did it become so enormous so rapidly? Molino theorizes that early galaxies acted as cosmic fast food spots for black holes, rich in gas and ripe for consumption. Yet, the sheer scale of these ancient supermassive black holes is baffling scientists. It's akin to witnessing a family with two tall teenagers and a toddler who's inexplicably just as tall. The question arises, how did this toddler of a black hole grow so large so quickly? Researchers are debating two principal theories to solve this cosmic puzzle. One suggests that these black holes begin small and gradually increase in size over billions of years by absorbing surrounding matter. The other theory proposes a cosmic shortcut. These black holes emerge as massive seeds from the get-go, originating from the collapse of vast clouds of gas and dust. Interestingly, our discovery of this ancient black hole leans towards supporting the latter theory, the heavy seed hypothesis. It's as though this black hole took a leap forward in its growth process, bypassing the gradual stages through a quirk in cosmic evolution. Yet, this revelation introduces a new twist to the narrative, challenging our understanding of the rate at which this black hole's consumption rate suggests that, in general, black holes might have the capacity to consume cosmic material more rapidly than previously believed. This is where the cosmic guideline, known as the Eddington limit, becomes relevant. It essentially places a cap on the velocity at which an object can amass mass due to the radiation it emits, which could otherwise repel the incoming material. During a black hole's voracious feeding periods, the more it consumes, the more intense the radiation it emits. However, overindulgence triggers the Eddington limit, which serves as a natural brake on this process. Yet, our recently identified cosmic outlier appears to be flouting these restrictions, feasting on matter at a rate 5 times beyond the Eddington limit. This scenario is akin to a competitive eating contest among black holes. Should this behavior persist for 100 million years, it may not have been necessary for it to begin as a massive black hole seed. It might have started off smaller post-Big Bang and still achieved its current colossal mass. The black hole's relentless consumption is not just about its own growth and power. It acts as a cosmic antagonist, disrupting the normal development of its host galaxy, Gien's 11. Despite being smaller than the Milky Way, this galaxy shines with exceptional brilliance. However, due to the black hole's insatiable hunger, it's hindering the galaxy's ability to grow, painting a picture of cosmic conflict. Ultra-rapid streams of particles are being expelled, clearing away the gas and dust typically responsible for star formation. Essentially, this black hole is acting as a deterrent to the creation of new stars within Gien's 11. The team responsible for this groundbreaking discovery views the Webb telescope as a pioneering instrument poised to reveal more ancient black holes. Roberto Molino is excited about the Webb, likening its introduction to transitioning from Galileo's archaic telescope to a state-of-the-art model overnight. He's exhilarated by the endless mysteries the universe holds, viewing this finding as just the tip of the iceberg. Another startling revelation by the James Webb Telescope is the existence of fully developed galaxies much sooner than our conventional models had anticipated. According to the prevailing cosmological theory, gravity coalesced dense regions of cooling cosmic gas, leading to the formation of stars and black holes, which then aggregated to form galaxies, a straightforward process, theoretically. However, James Webb's observations challenge this narrative, akin to encountering a scenario where parents and their offspring exist in a timeline where the grandparents are still youthful. Moreover, James Webb is stirring the pot with its contribution to the ongoing debate about the Hubble tension, which concerns the rate at which the universe is expanding. This has left scientists in a state of perpetual wonder, trying to reconcile their findings. In determining the universe's expansion rate, two primary methodologies are employed. One leverages measurements from the early universe, such as those provided by the James Webb Telescope, and the other involves calculating the distances between stars in our current era. This divergence has led to a somewhat theatrical situation where the standard model of cosmology, a cornerstone of our understanding of the cosmos, may be on the brink of a crisis. Despite being refined, it represents a pinnacle of human ingenuity, originating from Edwin Hubble's 1920s discovery that the universe is expanding. Over decades, it has matured into a robust framework underpinned by a fusion of hard-earned empirical evidence and complex mathematical physics. Yet, this model accounts for only about 4% of the universe as normal matter, with dark matter and dark energy comprising 28% and 68% respectively. Additionally, the concept of cosmic inflation posits that the universe underwent rapid expansion shortly after the Big Bang. Intellectuals such as physicist Lee Smolin and philosopher Roberto Mangabira Unger have begun to suggest that the principles that govern the universe, the fundamental laws of physics, might not be as immutable as once thought. John Wheeler, a renowned physicist, even suggested that each observation could influence the universe's past and future. Just when scientists believe they've unraveled the mysteries, new data emerge, challenging their conclusions and sending them back to square one. This iterative process, a blend of success and humility, is a journey that scientists willingly embrace. But what if we're at a juncture requiring more than minor adjustments? What if a comprehensive paradigm shift in our understanding of the cosmos is necessary? This challenge goes beyond simply identifying new components of the cosmic puzzle. It's about reevaluating the very essence of our cosmic comprehension. Cosmology, existing at the intersection of science and philosophy, urges us to ponder profound questions about time, space, the nature of laws, and our significance as observers. Within its inaugural year of scientific endeavors, the James Webb Telescope has already provided a feast for our cosmic curiosity, from deep field explorations to infrared glimpses of Mars and Jupiter, marking a thrilling journey through the cosmos. The telescope's emphasis on the cosmic dawn, the era roughly a billion years after the Big Bang, is revealing secrets of the early universe. And in case you missed it, NASA continues to capture breathtaking images of space, showcasing the fascinating interplay of light. The spectacle of light displays in the cosmos is utterly astonishing, and topping the list of celestial beauties is the aurora. Have you ever marveled at those mesmerizing lights adorning the night sky? I recently came across an awe-inspiring photo captured by NASA astronaut Josh Cassada, which is truly otherworldly. The surreal allure of the aurora borealis, as seen from the vantage point of the International Space Station, approximately 250 miles above Earth, is breathtaking. During his tenure on the ISS/NASA's, Josh Cassada has been in the esteemed company of astronauts and cosmonauts, including Nicole Mann, Koichi Wakata, and Anna Kikina. Fortuitously, he had the best seat in the house to witness one of the most exclusive spectacles the universe has to offer, the aurora borealis. While there are numerous stunning photographs of the aurora taken from Earth, the perspective from space is unparalleled. In a generous act, Josh Cassada shared this remarkable experience on Twitter, alongside the mesmerizing photograph. He described the view as absolutely surreal, and I can't help but concur. It's as if he was handed a VIP pass to the most magnificent show in the night sky. Now, diving into the reasons behind the recent buzz around auroras, it appears there's been a cosmic celebration, and Earth is at the center of it all. Auroras are the result of charged solar particles. When charged particles from the sun decide to interact with molecules in our atmosphere, the result is nothing short of magical. This particular event owes its brilliance to a potent solar wind, a consequence of what's known as a coronal mass ejection. Picture the sun, in a moment of tumult, releasing a burst of energy that tears open a gap in its corona. This upheaval amplifies the solar wind's force, propelling vast clouds of solar plasma through space, with Earth as their destination. Upon colliding with our planet's atmosphere, these charged particles ignite an auroral spectacle that captivates all who behold it. Typically, to witness the aurora borealis in all its glory, one might venture to quaint towns in Norway, Finland, or Sweden. However, this event brought the Northern Lights to an unexpected audience, with a stunning display across the UK. Spectators in Scotland, Northern Wales, Ireland, and even southern England were treated to this celestial show. Imagine the aurora borealis unfolding over the historic Stonehenge. It's a scene where people gather, eyes skyward, capturing the vibrant colors as they sweep across the nocturnal canvas. This phenomenon is a rare gift from nature, offering a moment of enchantment for anyone fortunate enough to experience it. Participating in such a marvel is a dream for many, and the science behind it adds another layer of awe. The intensified auroras are akin to Mother Nature dialing up the brightness on our planetary light show. The sun's charged particles, upon colliding with Earth's atmosphere, orchestrate a vivid display of hues. It's as if the cosmos itself wields a paintbrush, sweeping across the night sky in strokes of green, pink, and purple. So whenever you find yourself lost in thoughts about the vastness of the universe, remember there are astronauts witnessing these marvels firsthand. Josh Cassada is among those living this dream, generously sharing glimpses of it with us. But there's more to the cosmic light shows than what's seen from Earth. The Webb Telescope has captured mesmerizing lights emanating from an exoplanet, sparking speculation and excitement about potential messages from extraterrestrial beings. Amidst this cosmic intrigue, there's a peculiar discovery that adds a layer of mystery. Using NASA's James Webb Space Telescope, astronomers have identified a brown dwarf known as WISA 1935, which exhibits its own auroral phenomena. While auroras on Earth, such as the northern and southern lights, are familiar to many, the idea of such displays on a brown dwarf introduces a fascinating twist to our understanding of these celestial events. Auroras on Earth emerge when charged particles from the sun interact with molecules in our atmosphere, creating those stunning light displays we admire in the sky. Interestingly, similar phenomena have been observed on other planets within our solar system, such as Jupiter and Saturn. The brown dwarf WISA 1935+ is particularly unique. Brown dwarfs occupy a curious niche in the cosmic hierarchy, sitting somewhere between the mass of gas giant planets and stars. They are larger than planets like Jupiter, but lack the mass required to ignite nuclear fusion, the process that powers stars. This has led some to refer to them as failed stars, though this moniker hardly does justice to their fascinating nature. Main sequence stars, including our Sun, are also categorized as dwarf stars. These stars spend the majority of their existence in the main sequence phase, where hydrogen in their core undergoes thermonuclear fusion, transforming into helium. This process is what keeps the star shining, gradually making it cooler, brighter, and larger over time. Among the subclasses of dwarf stars, red dwarfs stand out. They are the smallest and coolest of the main sequence stars, yet they represent a significant majority, about 3/4 of all stars in the Milky Way. Despite their modest size and temperature, red dwarfs play a crucial role in our understanding of the stellar population across the galaxy. Despite their prevalence, red dwarfs are challenging to detect because of their low brightness. Proxima Centauri, the nearest red dwarf to Earth, is situated in the Centaurus constellation. Characterized by their minimal mass and cooler temperatures, red dwarfs boast incredibly long lifespans, potentially exceeding the age of the universe itself. Then, there are the brown dwarfs, celestial bodies with masses below 0.8 times that of the Sun. These entities are incapable of sustaining nuclear fusion in their cores, which places them in a unique category between the mass of Jupiter and that of a standard star. Although referred to as brown dwarfs, their hues can span from orange and red to predominantly magenta. Yellow dwarfs, including our own Sun, are medium-sized stars that constitute about 10% of the stars in the Milky Way. With surface temperatures nearing 6,000 C, they emit a bright yellow or nearly white light. Notable examples include Alpha Centauri, AHU Ceti, and 51 Pegasi. The life cycle of a yellow dwarf culminates in its transformation into a compact, dense white dwarf following a transition through the red giant phase. Lastly, white dwarfs, or degenerate stars, represent the remnants of stars. They are exceedingly dense, containing a mass comparable to the Sun's within a volume similar to Earth's. Distinguished from other stars, white dwarfs do not undergo thermonuclear fusion, marking them as the final evolutionary state for stars not massive enough to become neutron stars or black holes. The dim glow of white dwarfs is attributed to the residual thermal energy they possess. These stellar remnants have long intrigued scientists, sparking debates over their density and gravitational forces. At the young age of 20, Subramanian Chandrasekhar calculated the maximum mass limit for white dwarfs, establishing that they cannot exceed roughly 1.4 times the mass of the Sun. Brown dwarfs, on the other hand, generate heat through the gravitational compression of their mass, and some can even initiate fusion of elements like lithium. However, these activities are ephemeral, causing brown dwarfs to gradually cool and dim over time, earning them a reputation for being somewhat lethargic in their cosmic duties. Their diminished enthusiasm for fusion means that as brown dwarfs age, they fade and become nearly invisible to conventional telescopes, though they continue to emit a gentle infrared glow from their earlier, more active years. To uncover the mysteries of these elusive objects, astronomers rely on advanced instruments like the James Webb Space Telescope, which excels in detecting the faint infrared light they emit. WISE 1935+ is particularly fascinating due to its solitary nature, situated far from any stellar companions, making it an object of considerable interest. Despite its proximity of just 47 light-years a short distance on the cosmic scale, it remained unnoticed until 2019. Its temperature is a mild 200 C, but what perplexes scientists the most is the auroral activity observed around it, a rare and captivating phenomenon for a brown dwarf. Auroras typically arise from charged particles emanating from a proximate star, yet WISE 1935+ lacks neighboring stars, raising the question of the particle's origin. It's akin to attempting to ignite a grill without a lighter, a genuine cosmic conundrum. Utilizing the Webb telescope for a more detailed examination, astronomers made a fascinating discovery: methane emissions. Indeed, WISA 1935 plus is releasing methane, a significant hint considering that on Jupiter and Saturn, methane emissions are associated with charged particles warming the atmosphere and generating auroras. This suggests a similar process might be occurring with this solitary brown dwarf. Normally, methane present in a brown dwarf's atmosphere would absorb infrared light, leading to a decrease in observed brightness. However, WISE 1935 plus was exhibiting the opposite behavior by emitting light. Scientists are contemplating a few hypotheses to explain this phenomenon. One possibility is that WISE 1935 plus has an internal mechanism producing the energy necessary for the aurora. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.